Welcome back, third grade friends. I am so excited to be with you today. It's Mrs. Hoffman again, and I hope you're ready for some math. Today we're going to look at fact families. So think back, way back to first grade. It seems like a long time ago, right? And think back to when you were doing little problems like 2 plus 3 equals 5. And then you turned that around and said 3 plus 2 equals 5. Those are fact families, and we're going to do that today, but we're going to use a little bit bigger numbers. For our lesson today, you just need a few things. You're going to need your student guided practice page that looks like this. It has all these triangles on the side. And you're going to also need a pencil. Try to make sure that pencil has an eraser because you just never know when you might make a mistake in math. And we want to be able to erase that away when we do. All right, before we get started, we're going to do a quick refueling break today. This is one of my favorites. We're going to do our 6 sides of breathing. And what I love about this is that this 6-sided shape is a hexagon, which is one of our math terms that we use. Today when we do this, we're going to go around our 6 sides 3 times. It's a lot of numbers, isn't it? What you're going to do is you're going to take a deep breath in, you're going to hold it, and then you're going to let that deep breath out. So if you'll sit up nice and tall for me. We're going to start right here. Are you ready? Here we go. Deep breath in. Let's hold that breath and let it out. Let's do that again. Deep breath in. Hold. And now let it out. Let's go around again. Here we go. Deep breath in. Hold that breath. Now let it out. Deep breath in, hold it, let it out. We're going to go one more time. Make this your best time. Here we go. Big deep breath in. Hold that breath, let it out. Last time. Here we go. Big deep breath in, hold it, and now let it out and relax. Great job, guys. Okay. Let's take a look at what our goals are today. Today our goal is that we're going to relate addition and subtraction facts to find unknown numbers. So we need to know about fact families. So take a look right here. This is a fact family. There's a couple of things I want you to notice about this. I want you to remember this number on top here is always going to be our sum. That's going to be our biggest number. And if we add the 2 numbers in the bottom corner, those are going to give us that sum at the top. So for example, if I take 4 plus 6, then I'm going to get the number 10. And remember with fact families and what we know about the commutative property is that we can take those 2 add-ins and we can flip them the other way. And we can do 6 plus 4 equals 10, right? And remember a fact family also has a set of subtraction facts that go with it. So I'm going to take that 10, I'm going to put it over here, and this time I'm going to subtract. I'm going to start by subtracting the 4. What number is missing from my number sentence? Right, 6, because 10 minus 4 is 6. Now I'm going to switch some numbers around again. I'm going to start with my 10. I'm going to take away my 6, and what will my answer be? Perfect. So this is our fact family. This is how we're going to do our math today. Now remember, our numbers are going to get much larger, but if you hang with me and you remember everything we've done so far, you're going to do this with no problem. All right, very quickly, let's watch a quick video. I want you to pay really close attention as we're working today.
Laura had a bag of marshmallows. She and her friends ate 26 marshmallows. There are only 7 marshmallows left in the bag. How many marshmallows were in the bag to begin with? In this lesson, you will solve for unknown amounts by using addition and subtraction fact families. Let's review. You already know that for any 2 add-ins, we are able to write 4 addition and subtraction equations. For example, if our add-ins are 17 and 8, we can create the facts 17 plus 8 equals 25, 8 plus 17 equals 25, 25 minus 8 equals 17, and 25 minus 17 equals 8. Knowing that almost every addition or subtraction equation has 3 equations that are related helps us solve equations with an unknown value. You may see fact families represented in a triangle like this. The sum is always the largest number, and it will be on top. The 2 add-ins will be underneath. Sometimes you will be asked to answer a question where an add-in is missing. 9 plus blank equals 22. To solve a question where an add-end is missing, write out the 4 fact family equations until the missing add-end is on the right of the equal sign and solve. Our sum is 22, our addends are 9 and some unknown value. I'll start by writing out blank plus 9 equals 22. 9 plus blank equals 22. 22 minus blank equals 9, and 22 minus 9 equals blank. Ah, there we have our unknown on the right of the equal sign. We can use this equation to solve for our unknown. 22 minus 9 equals 13. That means our unknown value is 13. A common mistake is to use the opposite operation to solve for any unknown. For example, if you have the question 30 minus blank equals 12, you may think all you need to do is reverse the operation and add 12 plus 30 to get your unknown value. However, when what is missing is the smaller number in subtraction, or the subtrahend, you must set up another subtraction problem to determine the unknown. 30 minus 12 will give you the correct answer. Let's take a look at this question. When the sum is the unknown, you can use the same process. You may encounter a question such as blank minus 6 equals 38. You can create a fact family triangle and then write out your 4 equations. 38 plus 6 equals some unknown value. We know that blank minus 6 equals 38, which means that blank minus 38 equals 6. We also know that 38 plus 6 equals our unknown, and that 6 plus 38 also equals our unknown. 38 plus 6 equals 44, and that is our unknown sum. Let's take a look at our original question. Laura had a bag of marshmallows. She and her friends ate 26 marshmallows. There are only 7 marshmallows left in the bag. How many marshmallows were in the bag to begin with? Let's think about the numbers we know and the number that is unknown. We know that 26 marshmallows were eaten or taken away. We know that that left 7 marshmallows in the bag, which means that some amount minus 26 equals 7. What we're trying to find is the amount of marshmallows in the bag to begin with. Something minus 26 equals 7. Another related fact would be something minus 7 equals 26. An addition fact that is related would be 26 plus 7 equals our unknown. Or we could switch it around and say 7 plus 26 equals our unknown. 7 plus 26 equals 33, so the number of marshmallows in the bag to begin with is 33. In this lesson, you have learned how to solve for unknown amounts by using addition and subtraction fact families.
All right, so let's see if we can apply what we've learned. So take a look here at this fact family triangle. You notice that up on top we've got 32. That's our sum. That's going to be our largest number in this type of equation. Down at the bottom we've got our addends. Do you notice that 1 is missing? So we're using a question mark to represent that unknown number. So if I'm looking on the side over here, I've got 4 different equations that can help me solve to find that missing number where our question mark is. So remember, what I'm looking for is where in which equation can I find the question mark on the right-hand side of that equal sign. So in other words, I don't want my question mark to be on this side, I want it to be over here. So when I look at this first equation, I notice that my question mark is still in the middle. That's not going to help me find that answer yet. Let's look at the next addition problem. Again, I've got that question mark on the left-hand side, so I don't want to use that one either. When I look at 32 minus my unknown number equals 18, I still have my question mark or my unknown number on the left side. So I'm going to come all the way down here, and look what I found. I noticed that in this equation, my question mark or my unknown number is on the right-hand side of the equal sign. So to find that unknown number, all I have to do is 32 minus 18. Now, we used a couple different strategies when we solved these before, so I want you to choose a strategy and help me solve this. We can use base 10 blocks where we draw that 32 and take away 18, or we can use our open number line. I think for this one, the easiest thing for us to do is going to be to use that open number line. So grab your pencil and let's draw that open number line. Remember, a number line starts on one side with an arrow, goes all the way across to the other side, and ends with an arrow. An open number line is going to start with our smallest number, our 18. So let's put it over here. And do you remember what it will end with? Perfect, it's going to end with our large number, 32. Now remember, on our open number line, we want to try to make as few jumps as possible, but we want to find those friendly numbers between. So I want to go from 18 to my next easiest friendly number, which I'm thinking is probably going to be 20. How many did I have to hop to go from 18 to 20? How many spaces are between there? That's right, 2. So here I've got 2. All right, now I need to go from 20 to 30. How many jumps did I make there? How many spaces? Good, 20 to 30 is going to give me that 10. Now to go from 30 to 32, that's a simple one, right? That's just 2. To add all those numbers together, that's going to give me my answer. So I've got 10 plus 2 plus 2. Is it okay that I wrote those in a different order? Yeah, because we know the commutative property is going to let us put our numbers in any order when we add. So if I do 10 plus 2, I get 12, and 12 plus 2 is 14. So my missing number from my fact family is going to be 14 because 32 minus 18 equals 14. That's how our fact families work today. This time I want you to try to help me come up with some of our fact families. All right, look at this one. Ooh, this one's a little different. Which number is missing? That's right, our sum is missing at the top. So we know that if we take these two add-ins and we put them together, then we're going to be able to get our sum. Now I already see that number sentence, that fact family sentence that has the question mark on the right-hand side, but can you help me fill in my numbers on those two other equations? If I've got one addition sentence that says 75 plus 124 equals my unknown number, what can I do with those two add-ins to form the next number sentence? That's right, I'm just going to switch them around. So I'm going to take that 75 and that 124 and I'm going to put them in the opposite places. So let's fill that in. 124 plus 75, whoops, I guess I don't need that extra little plus there, do I? Equals my question mark. Now I have two number sentences that can help me solve that problem. All right, well, let's look at this one. Some number minus 75 equals 124. Well, in my subtraction problem, I still have to keep my biggest number first, which is going to be that unknown number. So I'm going to start here with that question mark. But what number will I put here? Perfect. I'm going to subtract 124. And when I do that, what answer will I get? Exactly, 75. So now I need to choose one of these two problems up here to solve. And it won't matter which one I solve because I'm going to get the same answer either way. So let's decide. Uh-oh, something happened right here. Let's decide which equation in our fact family is going to help us find that unknown number. We're going to choose a strategy. Do you want to use base 10 blocks or properties of addition? Let's maybe use base 10 blocks this time. So let's think about this. To represent 124, I've got to remember how those base 10 blocks work. Well, I know that 100 is here. And to make 20, I'm going to draw two longs. And then to make 4, I'm going to draw my 4 units. So there's 124. What's the other number that I need to represent? Perfect, 75. Do I need to draw any hundreds to get 75? I don't, but I do need to draw some tens, right? How many? Perfect, 7. So let's do that. 1, 2, 3, 4, 5, 6, 7. I'm going to put those up there because that's okay. And how many ones do I need to draw? How many units? Yeah, 5. Here we go. 1, 2, 3, 4, 5. Now to get my answer, all I have to do is figure out how many base 10 blocks I have here. So let's start with our units here. How many single units do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to bring that right over here. How many tens do I have? Let's count this by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, I'm going to put that here. And how many hundreds were there? Perfect, just one, so 100. If I take all of those numbers and I add them together, what's 100 plus 90 plus 9? Yeah, 199. Great job, guys. Do you remember how we used those base 10 blocks before? They're great for adding, and it's a perfect strategy to help us with larger numbers. Let's try another one. Those look like some really big numbers. Seems a little scary, doesn't it? I think we can do this though. Remember that 671, the number at the top of our triangle, that's gonna be our sum. So it's gonna be our largest number. Our two numbers down at the bottom are our add-ins, which means if I add those two numbers together, I'm gonna get 671. So let's see if we can come up with the two equations that are addition equations that will help us find the rest of the fact family. Now remember, if I start with my two numbers down here, I'm just going to start in the bottom left. I'm going to start with 214. What number do I have to add to 214? That's right, we don't know. It's our unknown number. So let's use our question mark. When I add that unknown number to 214, I'm going to get the sum, which is 671. I'm going to put that up here at the top. Okay, so I know that my other addition problem is simply going to be found by taking those two add-ins and switching them around. So I'm going to take my question mark and I'm going to put it first. This is using that commutative property. And I'm going to move it to the front and put my 214 in the back, and I'm still going to get 671. But neither of those problems leave that question mark on the right-hand side of my equation, or on my equal sign. So I can't use either of those problems to help me solve to find the unknown number. So what I need to do then is figure out my subtraction problem. Well, remember, our subtraction problems have to start with our large number, or our sum. So I'm going to take that 671 and I'm going to move it here to the front. Let's do that. 671. Now, I need to take away something, so I'm going to take away that unknown number. So I'm going to put my question mark here. If I take away my unknown number, what number will I find? What will my answer be? What number is missing? Yep, 214. Well, that's a great number sentence, but it's not going to help me find my answer because I still need that question mark or that unknown number on the right-hand side. So let's see if we can rearrange our numbers again and see if we can make a number sentence with that question mark here. So what will I start with in my subtraction problem? Will I start with 671 or will I start with 214? Perfect. I'm going to still start with 671. What will I need to take away in order to find my unknown number? Exactly, 214. There it is. This problem right here is the one I can solve to find my unknown number. So let's do that. Base 10 blocks or an open number line. Let's stick with that open number line again. All right, here we go. What do we start with? Very good. We're going to start with 214, and we're going to end all the way over here with 671. That seems like a lot, doesn't it? But I think we can do it. Okay, I want to find my next friendly number closest to 214. I think to go from 214, my next friendly number is going to be 220. And that's going to give me a jump of 6. I want to find a really friendly number that will make it easy to get up to those high numbers. So now I'm going to try to count all the way up to 300. So I'm going to try to go from 220 all the way to 300. I'm going to count by tens. Are you ready? Do it with me. So 220 is where I'm starting. 230, 240, 250, 260, 270, 280, 290, 300. I have 8 tens. How much is 8 tens? Great, that's 80. You got it. Okay. Now I'm going to go from 300 all the way to 600. Are you ready? I'm going to count by hundreds here. 300 all the way to 600. So 300, 400, 500, 600. How many hundreds did I jump? Exactly. I went 300. Okay. To go from 600 to 670, I'm going to jump 70, and then one more to get to 671. All right, now I've got to rearrange these numbers and try to put them all together. Let's put our hundreds first. I'm going to start here. Let's see. I've got 300. Now let's do our tens. Well, I see 80 here and 70 here. And then let's do our ones. I see a 6 and a 1. Okay, let's group those using our associative property. So let's group our tens together and let's group our ones. So I've got 300. I'm going to have to come up here. I'm running out of space. Okay, what if I have 80 plus 70? Well, let's count by tens from 80. We're going to count by tens 7 times. So 80, 90, 100, 110, 120, 130, 140, 150. Oh my gracious, 150. There's another 100 there, isn't there? Let's add our ones. What's 6 plus 1? Perfect, it's 7. Okay, let's push these all together. 300 plus 150 is 450 plus 7 is 457. So my unknown number is 457. You guys did a great job with that. It was tough stuff, wasn't it? There's a lot of things to remember. I mean, gosh, we wrote 4 different equations. We used a strategy to find our answer, so we used that open number line. Then we used our commutative property and our associative property, and then we added. That's crazy. That's a lot of work. I'd like you to try this one on your own. Take just a moment. See if you can figure out how this works. It's exactly like the last one, but just with different numbers. Let's see how you do. All right, guys, let's see how you did. So I know that I have the sum at the top, which is that 732. But what I don't know is this unknown number here. I do know that if I take 568 and I add it to that unknown number, then I'm going to get 732. I also know that if I switch those numbers around and I put that unknown number first, I'm still going to get 732 when I add 568. When I switch my equations to subtraction equations, I'm going to do 732 minus my unknown number will give me 568, or 732 minus 568 will give me my unknown number. That's the problem that I need to solve to find my unknown number. Again, I'm going to use that open number line. I hope that you chose to do that too, but if not, it won't matter. You'll get the same answer. I'm going to start with 568, and I'm going to end with 732. So I'm going to go from 568 to 570 because that's a friendly number. And I'm just going to jump 2 here. Now, I want to go from 570 to 600. To do that, I need to make a jump of 30. Now I can go from 600 to 700, which is a jump of 100. And then I'm going to go from 700 to 730. That's an easy jump. And my last jump, whoa, goodness gracious, is 730 to 732. I'm going to use that associative and commutative property. I'm going to change the order of my numbers. So I've got 100 plus 30 plus 30 plus 2 plus 2. I'm going to use that associative property. Let's group those numbers and let's start adding. I'm going to keep my 100. I'm going to add 30 plus 30, which gives me 60. And I'm going to add 2 plus 2, which gives me 4. When I add all those together, I get 164. If you got that, give yourself a great big pat on the back. That's a lot of work for one problem. Let me show you something really cool that you can do. And there's a link at the bottom of your page for this. This is one big giant triangle. Now remember, I want you to think of this as one triangle. So 2 plus something is going to give me 5. So in your head, think about that real quick. 2 plus something. Yeah, great. 2 plus 3 equals 5. So what you're going to try to do is figure out all of these missing numbers. But now I don't know what number's here or here, so I can't solve that. But I can come up here and think, well, 14 plus something is going to give me 27. I want you to try those same strategies. Once you have this number, then you have another triangle here that you can fill in. Give that a challenge, give that challenge a try and see if you can do it. Thank you so much for joining me today. Today, your code word is going to be triangle because that's the shape we've been doing a lot. Have a wonderful day, guys, and I will see you next time. See ya.